Hey, what's up guys, Mr. Roark again. So we are now on the next unit, which deals with finding the missing side of a right triangle, and we use a formula we call Pythagorean Theorem. So Pythagorean, Pythagorean Theorem, okay? You're going to be using this quite a bit this year on the STAR test, and they're going to approach it, they're going to send it to you kind of from different angles. So I want to show you guys, there's 3 different ways to find the missing sides of a right triangle using Pythagorean Theorem, but I'm going to start off with finding the longest side over here, which is called the hypotenuse, alright? Pythagorean Theorem is simply this, it's a squared plus b squared equals c squared, okay? Now, in some of your previous years, you've learned that the opposite of addition is subtraction, the addition of multiplication is division. Here, the opposite of a number squared, so we'll say, for example, x squared, the opposite of that is the square root of x, okay? This information here on the bottom part is going to come back to help us out later when we do Pythagorean Theorem, a squared plus b squared is c squared. But to start us out, what I want to do is I'm going to go ahead and get us going on this first part, okay? The first thing you need to know on these triangles is that, for example, if I have this side over here, we're going to call this side over here A, okay? We're going to call this the leg. We're going to say that A is 3, all right? Down here, we're going to call this bottom part of the right triangle B, okay? And we're going to say that B is 4, all right? And we're going to say for the time being that we don't know what this missing side is, what C is, okay? We're going to use this formula here to find out what this is, and here's how we do it, okay? I'm going to take A, or 3 squared, so over here I'm going to do 3 squared, plus B, which is 4 squared, okay? Now again, I don't know what C is yet, so I'm just going to leave it as C squared, okay? I know that 3 squared is like saying 3 times 3, so 3 times 3 is 9. I know that having 4 times 4 is 16, or 4 squared. And again, I still don't know what c squared is yet, but I do know at this point that I'm going to add 9 plus 16. If I add 9 plus 16, I'm going to get an answer of 25, okay? And 25 is the same as c squared. Now, if you remember back at the very beginning, I said that if we have a number that's like, for example, x squared, the opposite of it is the square root of x. Well, right here I have 3 for this length here. Here I have 4. But it's pretty obvious that 25 is a little bit, or a lot, too long to be the length of c. I have 3, I have 4, 25? No, that doesn't make sense. So what I do is I take my 25, which in this case would be my c squared, and I do the square root of 25. Now what that means, what the square root of 25 is simply asking is which number times itself would give me 25. Well, I know 3 times 3 makes 9, 4 times 4 makes 16, 5 times 5 actually does give me 25, okay? And so my answer for C in this case is going to be 25, okay? I did A squared, 3 squared, plus B squared, 4 squared, equals C squared, and I got that big number, and then I just took the square root of it, okay? I realize this is the first time you guys have seen this. This is the very basic version of how to find Pythagorean Theorem, or use Pythagorean Theorem to find this long side, which again is called the hypotenuse, okay? We're going to approach it from different angles, like I said, in this unit, okay? If you guys have any questions, you guys know you can always come find me in room 12. Alright, thanks a lot, guys. See ya.